Okay guys, good morning. So let's start this lesson. Now next topic, that's a Dijkstra algorithm. Okay, in last lecture we have discussed the mid-sem exam paper, and then now start the Dijkstra algorithm. So unit 5 greedy algorithm, we have discussed few problems. Now next one, that's Dijkstra. Supreme algorithm, Kruskal algorithm, that's a minimum spanning tree algorithm that we have discussed before the mid exam. Now next, okay, job scheduling, that's also we have discussed. Okay, this one, graph shortest path, or you may say that it's a network design. So single source shortest path, that means source, that's a one only, and you are just finding the distance from that source to all other nodes, and that's a minimum. That's known as the Dijkstra algorithm. So graph is used to represent the distance between the two cities. Everybody is interested in just moving from one city to other city as quickly as possible. The single source shortest path is based on this, and in this problem, the shortest distance from a single vertex is called the single source is obtained. The algorithm is called the Dijkstra. Graph G of V comma E, V is a vertices, E comma edge is the shortest path from a vertex V0 to all remaining vertices determined. That's a task for this algorithm. The vertex V0 is called the single source, and all other the last vertex is called the destination. It is assumed that all distances are positive. So Dijkstra algorithm is applicable only for the non-negative, or you may say that it's a positive distance only. This algorithm does not work for the negative distance. Obviously, logically, distance cannot be negative, but in any case of any terms that should be, suppose it's negative, then we cannot apply the Dijkstra algorithm. Now process. So first select any sources that's given as per the question, or it may be any single source starting vertex. Make distance or cost that's itself that's a 0, and make all other nodes cost that's a infinite. That means initially that's maximum distance, and then we find out the minimum. So set of vertices in a queue, that's ABCD, that's given a graph. S is a set of vertices, and this is the algorithm. So D is a distance of S. Initially it's a 0. For all vertices, that is all the vertices capital V minus S. That means S is your sources. So we are just simply ignore the source, or you may say that except the source node we have to cover all other nodes. Okay, initially distance that's infinite. Initially source that's 5, that means nothing. Q, all the vertices. So while Q is not equal to empty, that means if at least one node in a capital Q, then we have to process or do this process, or just follow the iteration rule. If Q is empty, all the vertices we have covered, then stop. Okay. Small u, first of all, just simply find out the minimum distance. That's all the Q and comma distance. For all V belongs to neighbor. Now just simply consider its neighbor, which is the direct edge, which has the direct edge, and just make the summation. Distance of U. That means distance up to U from the source plus U to V. For example, I am at right now something like U. U is just something like a one node. So that's a distance from the source to you. Then we are just simply find out the distance or weight or cost. That's a u to v. So that's the summation of these two. If it is less than compared to direct distance from source. So if it is less than, then we have to update. Otherwise not. So this is the simple process. Time complexity n square. So n is a number of vertices or number of nodes. So let's take one example here. So how we draw or how we write the example. Okay. Guys, are you listening? Just give me acknowledgement. Are you listening? My screen is visible. Yeah, okay, Vidhi. Let's continue. Yeah. Thanks, Darshan, Srinaran. So let's start the example. How to solve the Dijkstra or how to apply the Dijkstra method. So this is the given graph. And this graph given something like here, it's number of nodes A, B, C, D, E, F, G, and H. Source, they have given us G node, that's left side bottom. So that's our source. They have given the distance. For example, here it's G to D. Just simply show the arrow here. G is a starting dot, and here it's an arrow. So G to D distance, that's a 2. Similarly, G to H, here it's a 3. Okay. And here E to G, that's a 7. Something like that. So initially, my source node, that's G. So rest all other nodes, I'm just simply making the infinite. That's our initial steps in a algorithm. This one. Distance of V is equal to infinite. So बाकी के सारे nodes, so I'm just writing here infinite. Except source. So H, A, F, C, B, D, and E. All have, I'm just simply writing the infinite. That's initial distance. Okay. Now Now select this G because it's given the source starting. So its own distance itself, that's a 0. This one. Now just simply find out the direct edge from the G. Direct edge from the G. So that there are two edges. That's a direct connection. G to D, D for Delhi, and second distance G to H. Okay. So let's how we can write this one. Here it's a U is a source node, W is a weight, or it may be cost, or it may be distance. Step 1, that's a U is equal to G because G is a starting node, source node. V, that's a H comma D. Why H comma D? Because it's a direct connection from G. Okay. Let me write here. It's take a snapshot and paste in a paint, so we can just keep the graph width on the screen. What happened? What happened? It's not working over here. Okay, I'm just making here snapshot of the graph. Okay, this is the our graph. Now, okay, now see just simply here step number one. That's consider the G. That's a small u starting source node. V H comma D because it's a direct connection. Okay, now just simply direct connection. Then just simply write here G to H. So D of U plus W U comma V less than D of V. So D of V initially it's infinite. That's initially we have written. D of U that's its own distance. That's 0 plus U to V. So that's a 3 because this direct connection. So 0 plus 3 and here it's infinite. So obviously 3 is less than infinite. Then we have to update. Similarly, G to D. So we will get the answer 2. Okay, so that's I'm just writing these two steps here. Just observe only three letters G, D, and H. G that's a 0 because it's a source. H and D initially it was infinite. Now it's updated 2 and 3. Then D is equal to 2 and H is equal to 3. So this is the first step, and you have to write here parent node. So that's here G because it's a direct connection. That's why. So this is our first step. So in S, that's our answer. That's only G, and remaining node these are the nodes. Now, out of this node from the queue A, B, C, D, E, F, and H. Out of these, just select the minimum distance. So we know that A, B, C that's infinite because initially this node are infinite, no update right now. D that's a 2, yeah D is a 2 and H is a 3, remaining all are infinite. Clear? If we write here something like this one, where I can write, okay let me write here. Okay, let me just I'm just making this table. Okay, this table in Excel sheet. So that's for the explanation. Okay, I'm just writing here A, B, C, D, E, F, G, H. Okay, initially here it's infinite, so I'm just writing here this one INF. D now it's distance 2. First was it's infinite, but now it's a 2. F that's infinite. G that's a source, so that's a 0. H first was infinite, now it's a 3. Okay, so this is the table, and out of this one, just select the minimum one. That's a D node. So now next iteration, step number 2, you have to select here D. You have to select here D. Okay, and also writing here parent node. So I'm just writing here parent node, or you may say that here it's selected D. Then make here it's a capital T, and here you are writing the parent node. That's a G. Now you are just selecting this one. Okay, so now just simply find out which are the edges that's direct connection from the D for Delhi. So the first one that's a E for elephant, and second one that's a F, E and F. Okay. So again, just here step number 2. Let's find out the first of all F. So D to F, distance of U. That means its own distance from source node. So D, that's a 2. Why 2? Just simply observe this table. Here it's a distance 2. That's why here it's a 2. Then U to V, that means D to F. So that's given in graph question. That's a 10. So 2 plus 10 less than infinite. Yes, F is equal to 12. So now you are updating here F 12. And parent node D for Delhi. Done. So that's the F. Second edge D to E. So D is on distance 2. And how much distance D to E? That's a 25. So total distance here 27. Parent node D for Delhi. Done. Now these are the remaining nodes A, B, C, E, F, and H. 2 that's already selected, means already done. G also done. Now out of remaining nodes, H. So let's select the H because it's a minimum distance 3, and here make the T. T for true means or you may say that it's selected. Done. Now next step number 3. This one. Select H. So let's find out the direct edge from the H. Only to H to A or H to B. So again 3 its own distance plus H to A, that's a 4. So 7 less than infinite. Yes. So just simply update here 7. Parent node H. Similarly B. So H on distance 3. 3 plus 9 12. So let's write here 12. Parent node H. Only 2 edges direct. Done. Now next step. So just find out the which are the unselected nodes. Unselected node, this one. These are the unselected. Let me write this one. Now which one has a minimum distance? Capital A. So that's the step number 4. Select capital A. Guys, are you getting, or is there any query up to this one? Any doubt or clear up to this one? How we select the nodes? All of you clear? Okay. If any query, then tell me, you may, you may interrupt. Okay. So let's continue. Now next node, capital A. So select this one. Select this one, then just remove this color here, and here it's a yellow color. Here make the T, that's a true, that means selected. Now just find out the direct edge from the A. So direct edge from the A, that's A to B or A to F. Only there are 2 edges, A to B and A to F. So let's find out A to F. So A that's on distance 7. Why 7? Because here it's a 7. On distance 7's A to F, that's given here 10. So 7 plus 10, 17. But F, that's on distance here 12. So 17 less than 12? No. It's greater than 12. So no update, no change. Ignore this path. So there is no update. Now similar A to B. A on distance 7. A to B here it's I think it's missing. Okay, that's why here it's here it should be 8. Okay, so 7 plus 8, 15. 15 less than 12. देखो क्योंकि B का इट्स ऑन डिस्टेंस 12, तो 15 लेस देन 12, नो चेंज, नथिंग, नो अपडेट. Now next step, how many nodes here remaining? Blue color 12, infinite 12, 27. Now here are two options. You may select B as well as F. Anyone, any select. So in my answer, they have select, okay, this one, capital B. So let's select this one, B. Okay. Now, direct edge from the B for Bombay. So that's B to E as well as B to C. B to E as well as B to C. So B to C, so that's a on distance 12 plus B to C, that's a 4, 16 less than infinite, yes. Then you have to update here 16. And here you may write the parent, that's a capital B. Similarly, B to E, on distance 10, B2 here it's a 12, so 22 less than 27, yes, so update here. If it is less than, then we have to update as well as update the parent. Okay. Initially here it's a infinite, then 27, now it's a 22, and we have updated here it's a parent node also. Okay, now only three options, 12, 16 and 22. So now select this one, F. So that will be the next step, and find out the direct edge. F से direct edge F to A, F to B as well as F to C, or this one also F to E. Okay, there are four edges. So let's find out the four distance. First of all, F to C. So here it's a 15 less than 16, yes. Then update here 15. And parent node F. Second, F to E. F to E, that's a 14. And here make the parent F. F to B. See, B already selected here. So no need to update. Obviously, it will just give the answer something like no change, or it may be just it will give the greater answer compared to existing distance because it's already selected as a minimum. Similarly, F2A, that's already selected. So now only two options, C and E, and out of this one minimum here it's E. So let's select this one. Done. Now E. So which are the direct edge from the E? E to D, but D already selected. D to G. G is also selected, means that's a source. So no update, nothing change. And last option select. Last remaining node, that's a C. And again check. But already nodes, all the nodes are selected, so no update obviously. And this is the final answer. Let's compare here. Yeah, this is the table. See, these are the parents H, H, F, G, then final F, D. Here it's a source node, so no parent. And G, distance 7, 12, 15, 2, 14, 12, 0, and 3. And all true, that means all the nodes we have covered. Here, so this is the Dijkstra algorithm. Now, just simply find out the path from single source. Source is a fixed G. Now, just simply give me the answer that suppose my destination node is a capital A. Capital A. Then you have to just simply backtrack. A is here. So what? Which node is a parent node for the A? H. Then H, parent node G. So you may say that here it's a G, H A. For example, destination node my that's E. So let's write the path for this one E. So that's my destination, and we have to just backtrack. Reverse में लिखना है. So E, then E का parent node कौन सा आएगा? F. Why F? Because here it's F. Just observe my cursor. Then F का parent node D for Delhi. D का parent node G. So this is the shortest path from G to E. And you may calculate distance also. G to D, or just direct distance, that's fine only. So minimum distance here it's a 14. Minimum distance here it's a 14. That's the answer. Here it will give this direct distance from source node. For example, G to E. So here it's a minimum distance 14. Why it's 14? G D. That means here 2. Then D के बाद F में जाना था. Where is the F? This one. 10, then 2. So 2 plus 10, 12 plus 2, 14. So this is the path. And you will get the direct distance from this table. And these all are the distance which is a minimum distance, shortest distance from starting node G. So this is the process how you write the answer. Step by step you have to select each and every nodes, and you have to maintain this table. And this table is here our. Clear? Any doubt, any query? If any query, then you may ask. All of you clear or any doubt? Okay. Again, I want to just give a quick overview within a 1 minute, and then I will give one more example. Clear? Okay. This one, and we have to maintain this one. Okay. Okay, this is our given graph. So what is our first step? First step, just select our source node that's most probably given in a question. So that's 0 remaining all infinite. Done. Now, step 1, जो भी source node दिया है, that we have to select and just find out the direct edge. And for the direct edge, you have to write that distance. For example, here it's a 2 and 3, and write the parent node G. This is our first step complete. Now out of this direct edge, or means direct options D or H, select minimum one, and same process repeat each and every for each and every nodes, and we have to maintain this table. Okay. Anyway, let's solve one example. Oh, there is one here example. Okay, this is the just final answer. How we just simply backtrack. Okay, there is no example here. Anyway, I'm just give one example here and draw in this paint. Okay, I'm just give you a minute so I can give the example. This is my source node starting. Here it's the next node U. Here next node V. Then X and Y. Okay, now I'm just making the arrow here, or you may say that it's a connection or edge. So source node is a S starting. So you may start your example. Two. Here it's a 3. X2V, that's a 9. These are the connection. That's a 1. This distance, that's a 2. Okay, here it's a 4 and 6. Four and 6. I think all the nodes done with the last one that use this one. Okay, this is the complete graph, and just simply find out the distance for all the nodes from starting node S. So all of you try to solve this example. Okay, guys, just simply take a snapshot for this one and try to complete this example before the next lecture, and I will give the answer of this example in the next lecture. Right now, I have to stop this or means suspend this lecture right now. So just take a snapshot for this question and apply the Dijkstra algorithm. And guys, one more thing that just simply uh, write complete enrollment number in a chat box without class name, without branch name also. Just only enrollment number in a chat box. First of all, just take a snapshot for this one. I hope all of you have taken this snapshot. Okay, now just drop your enrollment number in chat box and then leave. So after all of you leave, then I will stop the recording. And guys, I have uploaded assignment on e-content as well as Google Classroom. So try to solve that assignment also. So all of you post your enrollment number in chat box. Am I right? After posting your enrollment number, please leave the meeting. So I just verify that all of you post your enrollment number, and then I will stop the recording. Guys, all of you just simply post your enrollment number and then leave.